A ball will always roll down a slope, not up. Similarly, an electric current will always flow in a particular direction in a circuit. Let's find out how. Take two glass tubes, A and B, and connect their lower ends by a rubber tube. Apply a clamp at the center of this tube. Fill water in both the tubes up to different levels. Now, if the clamp is removed, water begins to flow through the rubber tube. The water flows from tube A having high water level to tube B having a lower water level. Water stops flowing when the water level in both the tubes becomes equal. That means when the difference in the water level of both the tubes becomes zero. We've already seen that work done in bringing a unit positive charge from infinite distance to a particular point in an electric field gives the electric potential at that point. We can also say that acquisition of positive charge raises the level of electric potential at that point or on the surface of the body. As we observed in the example of glass tube with different water levels, consider two bodies having different electric potential levels. The difference in electric potential between two bodies is called the potential difference. When such bodies are connected with each other, the charge flows from the body at the higher electric potential to the body at the lower electric potential. The charge stops flowing when the electric potential is the same in both the bodies and the potential difference becomes equal to zero. Now, in the example of tubes containing water at different levels, arrange an outlet at the lower end of tube B. A beaker is kept at its base to collect the water. Now arrange a water pump to supply water from this beaker to tube A continuously. This way, water would constantly flow from tube A to tube B and from the outlet of tube B into the beaker. Hence, the water pump maintains the height of water in tube A. We can say that the flow of water resulting in the whole arrangement is regulated by the water pump. Similarly, a battery also maintains the potential difference between two ends of a conducting body through this wire. As a result, the charges flow through the wire, resulting in the flow of current. Let us understand this in detail. A battery has two terminals. One is positive terminal, the other is a negative terminal. Consider 2 points A and B located near both the terminals within this battery. The electric field will be in the direction from point A to point B. Now consider the positive test charge, which has to be moved from the negative to the positive terminal point B to A. The battery supplies energy and moves the positive charge in the direction opposite to that of the electric field. As a result of this work done, the charge gains electrical potential energy when it reaches point A. Due to this increase in potential energy, the charge has high electric potential at point A as compared to that at point B. Hence, the positive terminal of a battery behaves as a high potential terminal, whereas the negative terminal behaves as the low potential terminal. When this battery is joined in a circuit, the charge possessing the high electric potential will start flowing from the high potential terminal to the low potential terminal. When the charge comes across any circuit element, like an electric bulb, the electric potential energy of this charge is transformed into light energy. So when the charge comes out of the electric bulb, it loses its energy and returns to the low potential terminal, that is the negative terminal of the battery. Hence, batteries supply energy to many such positive charges, pumping them to high potential terminals. These charges naturally flow through external circuit to reach the low potential terminal. In this way, the battery maintains a potential difference between two ends of the conducting wire. So we can say, just as the water pump regulated the flow of water In the previous example, the battery re-energizes the electric charges, thereby causing a continuous flow of conventional electric current from the high potential terminal to the low potential terminal. The potential difference between 2 points in an electric field is defined as the work done in taking a unit positive charge from one point to the other against the electric field. Assume that work W has been done to bring the positive charge Q from point B to point A against the direction of the electric field. Let VA be the electric potential of charge at point A and VB the electric potential at point B. Then the potential difference between these 2 points can be given by V is equal to W over Q. Or it can also be given by V is equal to VA minus VB. That is the difference in electric potential between both the points. The SI unit for electric potential is volt, and it is the same for potential difference also. That is volt symbolized by V. Potential difference is also called voltage. A battery showing the rating of 12 volts means that it does 12 joules of work on 1 coulomb of charge before it reaches the positive terminal. This 1 coulomb of charge flows through the external circuit and its 12 joules energy is completely transformed in other forms of energy, after which it returns back to the negative terminal to be re-energized by the battery. It should be noted that 1 coulomb of charge is equal to 6.25 into 10 to the power 18 elementary charges. Now it's time to summarize what we learned so far. The difference in electric potential between two bodies is called the potential difference. Charge moves from a higher potential to a lower potential. The potential difference is also called the voltage. It is the work done in taking a unit positive charge from one point to the other against the electric field. It can be expressed as V is equal to W by Q. Its unit is the volt. Quantitatively, we've got two important quantities to analyze in an electric circuit. First, the rate of flow of charge, that is current, and second, the potential difference. We will study the law of physics that relates these two quantities and in the process discover a new one. Stay tuned to explore their relationships.
Keep imbibing. We believe in you.